12 right cylinders are filled with a blue gel. The largest cylinder has a radius of 18 centimeters and a height of 64 centimeters. The second largest has a radius and height equal to 90% that of the first cylinder, and the third largest has a radius and height each equal to 90% that of the second cylinder. The process continues to the 12th largest cylinder. We are required to show that the sequence of volumes, written in decreasing order, is a geometric sequence. The radius and height of the first cylinder is 18 centimeters and 64 centimeters respectively. Each successive cylinder has a radius and height that is 90% of those of the previous cylinder. The radius of the second cylinder is therefore 16.2 centimeters, and the height is 57.6 centimeters. The radius and height of the third cylinder is then 14.58 centimeters and 51.84 centimeters respectively. We are required to show that the sequence of volumes of the cylinders form a geometric sequence. In other words, we need to show that there is a common ratio between successive terms of the sequence of volumes. There are a couple of approaches you can take with this. The simplest approach would be to determine the actual volume of the first three cylinders, since we have determined the radius and height of each of the first three cylinders. Now that we have the volume of the first three cylinders, we can simply determine the value of the ratio for successive terms of the sequence. Since the ratio V2 over V1 equals the ratio V3 over V2, we can state that the sequence of volumes of these cylinders forms a geometric sequence. A neater approach, and not necessarily any more complex, would be to determine the volume of each cylinder in terms of pi, r, and h. The volume of the first cylinder equals pi r squared h. The radius of the second cylinder is 90% that of the first cylinder, so the radius equals 0.9 r. Likewise, the height of the second cylinder equals 0.9 h. The radius of the third cylinder is 90% that of the second cylinder, so the radius of the third cylinder equals 0.9 times 0.9 r. And the height of the third cylinder equals 0.9 times 0.9 h. We can now find the simplest expression for each cylinder's volume in terms of pi, r, and h. The ratio V2 over V1 equals 0.9 cubed, as does the ratio V3 over V2. We can therefore state that the sequence of volumes of these cylinders forms a geometric sequence, since there is a common ratio between successive terms. The last thing we are required to do is to determine the volume of gel, in liters, required to fill 12 cylinders. In other words, we need to determine the sum to 12 terms of this sequence. The first term equals 20736 pi, the common ratio equals 0.9 cubed, and the number of terms is 12. The sum to 12 terms is, therefore, 234968.54 centimeters cubed. We are required to leave the answer in terms of liters, so we now divide this answer by 1000, which gives a final answer of approximately 235 liters. 1 centimeter cubed equals 1 milliliter, and 1 decimeter cubed equals 1 liter. The conversion from centimeters cubed to liters therefore becomes very simple.